What are the properties of a dark matter halo? Imagine a giant invisible bubble surrounding galaxies, holding their structure together like an unseen skeleton. That's what scientists call a dark matter halo. These halos are essential for understanding how galaxies form and stay intact. They are not visible to the naked because dark matter does not emit, absorb, or reflected light. Instead, we infer their presence by observing how galaxies move and how light bends around them. Dark matter halos are incredibly dense compared to the universe's average density. They are about 100 times denser, which helps keep galaxies from flying apart. Inside these halos, the matter is in a state called virial equilibrium, meaning the gravitational pull inward balances the particles' random motions outward. This balance keeps the halo stable over billions of years. The shape of these halos is usually not perfect spheres. Instead, they tend to be triaxial, meaning they are elongated like stretched ellipsoids with 3 different axis lengths. Their shape can change depending on their environment. For example, halos in crowded regions tend to be rounder, while those in emptier areas might be more elongated. The way dark matter is spread inside the halo follows specific patterns. The classic model is called the Navarro-Frank-White profile, which describes how density drops smoothly from the center outward. More recent studies suggest the Einasto profile fits better, showing a gentle decrease in density as you move away from the core. Dark matter halos vary greatly in size and mass. Some are small enough to host tiny galaxies, while others are massive enough to contain entire galaxy clusters. The size and mass influence how much gravitational pull they exert, shaping the galaxies that form within them. Unlike normal matter, dark matter particles do not lose energy through radiation or collisions. This means they cannot clump tightly into objects like stars or planets. Instead, they remain spread out, forming a diffuse halo that extends far beyond the visible parts of galaxies. The properties of halos depend on their location in the cosmic web. Halos in dense regions tend to be larger and grow faster, while those in voids are smaller and evolve more slowly. This environmental influence affects their shape, size, and growth history. Dark matter halos act as the scaffolding for galaxy formation. Gas and dust fall into these gravitational wells, eventually forming stars and planets. The total stellar mass of a galaxy is closely linked to the mass of its dark matter halo, especially for smaller galaxies. Some galaxies, called ultra-diffuse galaxies, have halos that are quite different. Their dark matter is less concentrated near the center, making these halos odd compared to typical galaxy halos. This unusual property affects how stars are distributed and how the galaxy looks. In galaxies like our Milky Way, the dark matter halo extends far beyond the visible disk. It can contain up to 95% of the galaxy's total mass, influencing how stars and gas orbit and move. Even though dark matter halos are so massive and influential, they remain invisible because dark matter interacts almost exclusively through gravity. Studying their properties is a challenge, but it helps us understand the universe's structure and the mysterious nature of dark matter itself.